So we're going to be talking about reflections, and at the very top, the word that you might use for a reflection is, let's write it right here. It's a transformation where you flip the figure over a line. So we flip it over a line. Yep, and that line, it's got a special name. It's called the line of reflection. Fancy name, right? If you're reflecting it over a line, we're calling it the line of reflection. All right? So, we're going to deal with mostly the axis, X and Y axis, but we're going to deal with some other stuff too. Let's take a look here. So we got A, B, C. We are being asked to reflect it over the X axis, which is this axis. So what value is going to change? I like to start with this. X, Y, if I'm reflecting it over the X, what's going to happen? If I'm reflecting it over this line, what value is changing, X or Y?
X.
X moves it left or right?
Or Y.
Only the Y. So it's actually going to become X and then the opposite of Y. If we reflect it up, Y is going to be the same distance away from the X axis, just on the other side, right? So the opposite of Y. So let's start by writing our coordinates. For A, we have 1, negative 3. We have for B, 3, 0. And C, we have 4, negative 2. And if we're going to flip it over the x-axis, y becomes their opposites. So our three coordinates are going to be 1, 3. 3, what's the opposite of 0? Negative 0?
0.
That's just 0. Negative 0 would be cool. It was my number when I was a volleyball manager. Meaning like I was the team manager. All right. So, A prime is going to be 1, 3. B prime is 3, 0. What do you notice about B and B prime?
They're the same place.
Yeah. And C prime is going to be 4, 2. Do my best to make straight lines. I was making some good lines last time, wasn't I? Nailed it. Oh, that's freehand, perfect, yeah. So, our image, well, we already wrote the rule. XY becomes X negative Y in this case. Do we think it's congruent or similar? Congruent, yes, it's the same exact, it's the same size and shape. And this type of transformation, just like translations, is called a rigid transformation. Rigid meaning it hasn't changed what the shape is. It hasn't changed the size or scale or anything. That's why it's called rigid. It's like you could take the same thing and just, if you could physically pick it up and move it, it would just be the exact same. All right, guys. So who can tell me what's different about example 2? What's example 2 asking for? Yeah.
The y-axis.
The y-axis, which is this line right here, right? So let's start with our ordered pairs again. We have 1, negative 3. They're the same, right? 3, 0. And you have 4, negative 2. So this is Beyonce's favorite one to do. Watch my hand. If we're going over the Y. Get it? Yeah. All the single ladies. Cross the Y. Get it? See? Look it. I'm going across the Y-axis here. Nobody gets it. It's just not funny.
That makes sense.
You could just like half laugh just to make me feel better sometime. Okay. Anyway, so what's changing, the Y or the X value?
Yes.
If you ever forget, I've had a year where kids are doing this during the quiz. I'm like, yes. You might not laugh at my joke, but you know how to reflect across the Y-axis. Okay. No, not across the Y-axis. It's not going up or down at all. It's going left and right. So, the Y-axis is going to make XY change to negative XY. So, when I get my new points, they're going to become negative 1, negative 3, negative 3, 0, and negative 4, negative 2. So negative 1, negative 3, here's my A prime. Negative 3, 0, here's my B prime. And negative 4, negative 2 is my C prime. So just changing those to the opposites, flipped it across the y-axis. Notice it did not go up and down at all, right? So that's why there's no change in y values. And then this one didn't ask for it. Are they congruent or similar?
They're congruent.
They're congruent. Same size and shape still. We just flipped it. Titus.
Why doesn't it share the same thing as when we did the x-axis, it shared a point?
Yeah, because when we flipped it across, because that point was on the x-axis.
Oh.
Good question. Okay, guys, so let's start. You're going to make that first triangle JKL. We got 0, 2 for J, 3, 4 for K, and 5, 1 for L. So this is our pre-image. This is what we're starting with. And what does it say that it wants us to do to get our image?
Find the reflection of the x-axis.
Over the x-axis. So, over the x-axis, that's a change like this. See my hand? I like to do this. So what's changing, x or y?
Why?
Y. So xy is going to become x negative y. I like to do the rule and just get my points and then graph my points. So I get 0, negative 2 for j prime. I get 3, negative 4 for k prime. And I get 5, negative 1 for L prime. And I should look at, I don't know what it is. Is it double prime? I don't know. I should know what it's called when there's 2 prime. Super prime. That's what I'm going with. So let's write down our coordinates. 0, I'll hold up in a second. 0, negative 2, 3, negative 4, 5, negative 1. Those are where we're starting out with our new image. So to make our new image, we have to go over the y-axis. And what's happening to go over the y-axis? Our xy is changing to negative x. Y. We're flipping left to right, which is a change in x value. So negative xy on those is going to give us 0, negative 2, negative 3, negative 4, and negative 5, negative 1. Titus, there's that one you were asking about. See how it's the same point this time? It's because it was on the axis. So there's J double prime. K double prime is negative 3, negative 4. And L double prime is negative 5, negative 1. It's a good day to have practice organization, huh, guys? Things can get cluttered up on here.
I don't get numbers at letter.
Cool picture, guys. I'm digging it. All right, so describe a different combination. So instead of reflecting the x and reflecting the y, is there a different way we could have started with our original and still gotten to the red one? Instead of going reflect x, reflect y, is there another way? Yeah, I think that would work. So reflect y first, then x. It'll work, right? Here's something else that's cool. If you look at our two things, what do you notice right here? What do you notice we did? If we combine the two things we did, is there a way we could have went from the first to the last? We could have just went negative x, negative y from our original, right? And that would have gotten us there.
Oh yeah, because C goes down to 1.
Yeah. And here's the deal. Remember where your black one is and where your red one is. Okay, remember where black and red are. And then physically take your paper and turn it 180 degrees. Or put your top at your bottom at the top. Try that out. So remember where the black and red are. What do you notice when you flip it like that? Spin it like that, I should say. It's the same. So this, just to give you a little preview of tomorrow, that double over the x over the y, that's actually the same as 180 degree rotation. Is it congruent or similar? Congruent. It's the same size and shape. This is still a rigid transformation. All right, guys, example 4. I'm going to put in a line of reflection. I like putting in the line of reflection. It's x equals negative 1, and that is this line right here. You see that little dashed line I put in? That is the line of reflection. So instead of the y-axis, that's what we're reflecting across. So let's get our 3 points. We got A, B, and C. Got this triangle go. Oh, don't want there. Got this triangle here. And instead of the axis, our line of reflection is x equals -1. So, do you guys see that this would be A prime right here? This would be B prime right there. And that would be C prime right there. So this one's different because we're not reflecting across y-axis. We're reflecting it across x equals -1. What?
Isn't it 0, 1? So wouldn't it not be
0, 1 is A on the black. That's right.
so?
But it's telling us to reflect across this line, not the axis. So then B prime is -5, 4. And C prime is -7, 1.
Wait,
Isn't the first one -2 and 1?
It is -2, 1. Thank you. Thank you, Charlie. Okay.
I'm confused.
So they're all, guys, just notice left to right, they're all equidistant from that line, x equals -1, right? Check out right here.
oh, equidistant.
1 away, 1 away. 4 away, 4 away. 6 away, 6 away. So instead of the y-axis being our line, x equals -1 is our line, our reference reflection line. You could also imagine once you get your answers, if you were to fold your paper on that reflection line, that they would match up perfect, both sides, right? That line of reflection.
You should go to Merriam-Webster and have them.
So let's try, just next level. If we wanted to go right to point, what's happening to our x? What's a rule happening to our x?
It's opposite thing. Oh no, x -1.
So, I'm not seeing -1. So it's flipping, right? So we got a -x. Let's start there. -x, and then what happens to our -x to get to our exit values?
Plus -2.
Yeah, -2. And here's the reason. From A to the line, there's 1 there and 1 there. Are you guys seeing that? Here's 1. Here's 2. Right? Because it's the same on both sides from distance away, from the axis. It's 1 away from the axis on this side, 1 away from the axis on that side. Because I'm at -1. So it doubles that distance from the axis. And then what happened to our y values? Nothing. Cool. All right, guys, so this one's kind of similar. I'm going to write in the dashed line of reflection, y equals -2. That is this horizontal line right here. So that's our reference point instead of the x-axis. Give me a hard time making the arrow. Okay. Let's do this class. So let's put down our A0, 1. 3, 4 is our B. And C is 5, 1. So there's our triangle. And we're going to reflect it across this axis. So I like to count how many away I am. 1, 2, 3, 1, 2, 3. So that's how I got my A prime. 1, 2, 3, 1, 2, 3. That's how I got my C prime. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's how I got my B prime. So instead of across the x-axis, I'm going across this line, y equals -2. And I get points 0, -5. B is 3, -8. And C is 5, -5. Let's look at our rule. What's happening to x? Yeah, nothing's happening to x. So a reflection across the y-axis is a -y. And then what do I have to do to my -y? -4, because it's 2 away, kind of like on the 2 sides here. So if it's 2 away from the axis, it's 2. You're starting 2 away from over here as well. So it doubles that distance from the axis. So we could use this rule to just get our new points instead of drawing and counting. That's an option. They're asking for the line of symmetry, or the line of reflection, I mean. So are you guys seeing that this is the line of reflection? Okay? And the equation for that line is x equals 0. It doesn't matter where you're at on that line, what is the x value?
0.
You can't say y equals anything because y is all the things. It doesn't matter what y is. X equals 0, that's the line. So on number 7, did you guys all figure out that this right here is the line? And that line's equation is y equals -1. No matter where you're at on that line, the only thing you know is y equals -1. Doesn't matter what x is. What does y equal? -1.